Now we're going to talk about the law of signs, and in particular the ambiguous case that pops up sometimes when you're solving triangles. To get us there, I want to make sure we first solve this equation to remind you about what happens when you're solving an equation like this. We're going to solve for x if x is between 0 degrees and 180 degrees. I know often we've been working in radians, but because we're going to be solving triangles where we're going to be looking for angle measures in degrees, I thought we would do this in degrees. So to solve for x, we know we would punch it into our calculator, the inverse sine of 9/13. So the reference angle for this equation would be 44 degrees. Do make sure that you're in degree mode for these problems. But between 0 and 180 degrees, we're going to have two solutions because the sign is positive in the first and second quadrants. So we know that x could equal 44 degrees, or it could also equal 136 degrees. Both of those solutions are in the interval 0 degrees to 180 degrees. Now let's move to solving triangles. We're going to do 3 examples, not all of which are the ambiguous case, but these are the 3 that we're going to do so that you can understand when you have the ambiguous case and when you don't. So here's our first example right here. Suppose we're given a triangle where one angle is 32 degrees, one side is 15, and the second side is 11. So let me draw that picture. So here will be my angle A over here. It's about 32 degrees. Let's see, label that 32. We're going to be finding angle B. Let's see, side A is 15. It's longer than this side, which will be 11. Let me draw it. We're trying to find angle B. This is A right here. It's across from angle A. Oh, and it was given to be 15. B is 11. So now we can use the law of signs. We have an angle on the side opposite. We're trying to find this angle, but we have the side opposite. And before I continue, here's an important detail. I want you to notice that the information that we were given is 2 sides of the triangle and the angle that is not the included angle, the angle that is not in between those 2 sides. So often we consider this a side-side angle scenario. Let me write that right here. Side-side angle scenario. That's the only time where the ambiguous case could pop up. And I know I haven't told you what the ambiguous case is yet, but let's continue and it will be revealed as we move forward. So let's solve using the law of signs. So we have the sine of B over 11 equals the sine of A over 15, but A is 32 degrees, so let's put that in. Sine of 32 degrees over 15. Now often people cross multiply here and take a couple steps to solve for the sine of B, but we really don't need to. We could solve for the sine of B in one step by just multiplying both sides by 11 right here. The 11's cancel, and then I would have this sine of B equals 11 sine 32 degrees divided by 15. And now we could take the inverse sine of this ratio and find B. Just because I have a point to make, I'm going to take an intermediate step and write this ratio as a decimal. So the sine of B is approximately equal to, and then I punched this in on the calculator, and it's about 0.3886. So now we're solving an equation that's much like this one. And remember, there will be two solutions between 0 degrees and 180 degrees, those angles that could pop up in a triangle. So now when we do the inverse sine of this ratio, we find that B equals 20, I did the calculation already, 23 degrees. Right, I wrote equals, but we know it's really approximately equal to 23 degrees. And I'm just going to the nearest whole degree for simplicity. You could give more decimal places if you needed to. But if B equals 23 degrees, we know there is also a solution in the second quadrant, which we'd find by taking 180 degrees and subtracting 23 degrees, and we would have a 157 degrees. Now remember, these angles represent the measure of this angle. Now I don't care that it doesn't look like it could be 157 degrees, but because my picture could be misleading. But let's determine whether it actually could. Maybe my picture just wasn't drawn right. Is it possible that angle B is 157 degrees? Well, if we put 157 degrees in here, notice the sum of these two angles would already be over 180 degrees without even taking this third angle into account at all. So it is not possible that this angle B could be 157, because 32 degrees plus 157 degrees is greater than 180 degrees. So it's not possible. So the only possible value for angle B in this scenario is 23 degrees. It is not ambiguous. This is not the ambiguous case because there is only one angle possible. Let's move on to the next example. Notice I kept it very similar. A is again going to be 32 degrees. Side A is now only going to be 4, and side B is going to be 11 again. So let me draw that triangle. So here's my 32 degree angle. This and side B is 11. And now side A is shorter, it's only 4. So here's angle A, here's angle B. And again, our task is to find angle B, but we'll set it up much like we did the previous one. So we have the sine of B over 11 equals the sine of 32 degrees over 4. And let me point out again that the information that we were given was these two sides and the angle that was not in between them. That is again the side-side angle scenario. If we multiply both sides by 11, we'll have the sine of B equals 11 times the sine of 32 degrees divided by 4. Now often people find the inverse sine of this ratio on their calculator, and you could go ahead and punch that in. And what you'll find is your calculator is going to give you an error, or it might say error, syntax error, domain error, depending on what kind of a calculator you have. But let me take an intermediate step so you can see why that's happening. If we actually punch this in on our calculator to get the ratio, you have the sine of B equals 1.457, or approximately equal to that. Now we know the sine of an angle has to be between 1 and -1. This is not between 1 and -1, so this is not possible at all. No such triangle exists. So you might look at this and say, but you drew it. I know, but I didn't actually draw it correctly. Here's the actual scenario that's happening. If we draw it a little more accurately, this is 32 degrees here. B is still 11. Here's side A. or excuse me, angle A, side A is 4. Apparently it isn't even long enough to reach this side over here. So we don't even have a triangle. This side has to be long enough that it would hit this side for the triangle. So that's something that can happen sometimes. Now let's get to our third and final example. And notice I've given you very similar information. One more time for contrast. Oops, let's not run those together. So I'm going to draw a triangle again. This time B is 11, A is 32 degrees, and now side A is 9. So let me label my triangle. And we're again trying to find angle B. So we set it up much the way we did the previous two. Sine of B over 11 equals the sine of 32 degrees over 9. Multiply both sides by 11. We have the sine of B equals 11 times the sine of 32 degrees divided by 9. And we could just at this point type the inverse sine of this ratio. But again, I want you to see this intermediate step. So we have the sine of B is approximately equal to 0.6476. So again, we have an equation where there will be two solutions between 0 and 180 degrees. And if we take the inverse sine of this ratio, we find that B is approximately 40 degrees. But that's only the first quadrant angle. Here's the important part. We also need the second quadrant angle, which is 140 degrees. Now this time, 40 degrees is a possible value for angle B, but so too is 140 degrees. Because if we put 140 degrees in right here, 32 degrees plus 140 degrees is less than 180 degrees. So it is a possible value for angle B. Now I don't have it drawn that way. That's because this is the ambiguous case. There are two potential triangles that would meet this criteria, where A is 32 degrees, side A is 9, and side B is 11. One would look like this, and the other would be an obtuse triangle. Let me see if I could draw it much like this one. (32 degrees), but instead of the side A coming down this direction, in fact, it comes down this direction. And my picture doesn't look very lovely. But this is the 140 degree angle here, where this would be side 9 and this would be side 11. So there are two triangles that have angle A equaling 32 degrees, side A equaling 9, and side B equaling 11. And again, this occurred when we had the side-side angle scenario. So anytime this is the information you're given, consider the possibility that you have the ambiguous case.